All right, hi everybody. Happy Monday, February 9th. This is lecture 10. We're discussing section 7.1 today, which is area between curves. So, first thing I want to talk about is the area of a simple region. So if bottom of x and top of x are functions that are integrable integrable on the interval a to b, and they also satisfy this inequality. The bottom function is the bottom function. Its y values are less than or equal to the y values on the top function on that interval. So in this case, we're looking at a situation like this. So on this interval from a to b, this red graph is the top function, even though it crosses over later and becomes the bottom function. And then this green graph on that interval is the bottom function. Then this region is what I would call a simple region, something which fits these criteria. So then the unsigned area of the simple region is just this. A equals the integral from A to B of top graph minus the bottom graph. Seems fairly straightforward, kind of the obvious thing. The book presents a proof of this. The idea is that you imagine little rectangles that start at the bottom graph and go up as high as the top graph, and you get the area of those rectangles, and you take the limit as there are more and more rectangles getting skinnier and skinnier, and you get this. But in general, there are complications. Find the area bounded by the curves I'm going to make this a bit more interesting. Y equals 7 sine pi x, and y equals x squared minus x. So notice, neither of these is called the top graph, and we're not given an interval. So what do we do? Well, we have to... our only tool is this. So our only plan of attack can be, we have to figure out if there is a simple region. simple region, maybe plural. Maybe there's more than one simple region. We'll have to add up a couple of areas. Well, so how do we do this? How do we figure out the simple regions? Yeah, Mary?
Could you craft the function?
Yeah, okay. So how's that going to look? Who wants to graph? Okay, let's see. These are the sharks, and here are all the jets. So sharks, you all have to figure out how to graph this. And the jets, you have to figure out how to graph this. Sine pi of x. Sine pi x. Can't come up here alone. You have to have a, what do they call it, a second when you come dual. All right, so sharks, you got to get going on this. Jets, I'm not going to wait forever. You got to work together on this. I have not heard any desks scoot. Morgan's a jet. You're a shark. You are not allowed to work together.
Where's the split?
Right, you're the split. You are the ends of the sharks. Jets are over here. Oh, actually, you can recruit a jet to change sides. There you go.
Traitor. It's like Maria. It's basically just a sine. And it comes that out. So sine 1/2 pi is 1 multiplied by 7. Which also is 1/2.
Okay, who sharks versus jets. Anybody want to come grab chalk and claim the territory?
Yeah, it's going to be
You're the first to plot it. You can do this.
It's got to be huge.
Huge. Got it. Huge enough?
Huge. That's not huge. It's got to show up on Gabriel's camera back in the back.
Fair enough, fair enough.
You need to be big. What?
Rather quiet.
They're all raptured. We are enraptured with the graphing.
This is terrible.
Yikes. Oh, I said that. So mean. I have a little bit of bile just poured out of my soul.
All right, Jets just won this rumble, but how are the Sharks doing? Marcy, you can't come up alone though. You got to come up with somebody else. You got to. Do you have consensus?
Is this right? Do you? Yep. Okay. What's that?
Very nice, everybody. So, Liam, Ian, how did you decide that the x-intercept is there? Explain why that's, because doesn't the sine graph cross at 2 pi or a pi? Jace?
I mean, pi's already in.
Pi's already in there, exactly. So this red graph is sine of 7 sine of pi x. So I'm going to color this red because you can, well, this is y equals 7 sine of pi x. So when x is 1, then the thing inside of the sign, that is the argument, would be pi. And pi comma 0 is a graph, is a point on the graph of sine of x. Okay, Jets, how did you figure out that this is your graph? What's that?
Simple polynomial, so you can just factor it and then
Yeah,
solve for what makes x 0.
exactly. So this is this can be this is a polynomial facing up, and it factors this way. And so it has x-intercepts at 0 and at 1. And so now, a question for all of you on the count of 3. Tell me what is my interval? What is my A and my B? Ready? 1, 2, 3.
0, 2.
Mary, you look confused. You look outraged. What were you going to say? Or what did you say?
Well, I was thinking it was going to be between 0 and 1 because that's where...
Exactly. The only region that these two graphs enclose is here. So this is so all this work went into just figuring out the top graph and the bottom graph. And my interval. My interval goes from x equals 0 to x equals 1. So my area is going to be the integral from 0 to 1 of the top, so 7 sine pi x, minus the bottom, x squared minus x. Great. How'd I do? Need parentheses. Yeah, whenever I say how, those of you who didn't have me in the fall should figure out that whenever I say how'd I do, it usually means that I forgot some parentheses. You got to have parentheses there. Okay, so let's simplify this because I don't like having those parentheses. This is going to be the integral of 7 sine pi x minus x squared plus x. So this antiderivative is going to be minus 7 cos pi x divided by pi. You have to do a u substitution. And then I'm going to have minus x cubed over 3 plus x squared over 2. And that's all got to be evaluated from 0 to 1. So be generous and with ink or lead or chalk and space on the page, and make sure that you do your arithmetic carefully. So for instance, the dorky things that I do on the chalkboard, I do at my desk as well. So I'm going to have something minus something. A lot of people make mistakes by not having this second pair of parentheses. So just start by putting them there. You're going to have that stuff at x equals 1. So minus 7 cos pi times 1 all over pi minus 1 cubed over 3 plus 1 squared over 2. And then the same thing. Minus cosine of pi times 0 over pi minus 7 minus 0 cubed over 3 plus 0 squared over 2. Of course, those two terms are easy, but the other one's not easy. So what's cosine of pi? Raise your hand if you know that. Alexander, is your hand up? It's kind of up. Can't ask me, you got to tell me. Good. Minus 7 times minus 1 over pi. Minus 1 cubed plus 1/2. You're on a roll, Alexander. What's cosine of 0?
1.
Good. So notice all the minuses. We have 7 over pi, minus 1/3 plus 1/2 is 1/6. And then we have plus another 7 over pi. So we end up with 14 over pi plus 1 over 6. So the only thing hard, well, there were lots of little pieces. None of them, no single piece is that hard. But notice, again, we had to figure out the simple regions. So we had to figure out the interval. We had to figure out which is the top graph, which is the bottom graph. That's end of part 1. Part 2. Area between velocity curves. Yeah.
The signed area or the unsigned area?
Oh, so whenever we talk about area between curves, we always figure out it's always unsigned. It's always a positive thing, and that is we figure out the curve so that the integral is going to turn out to be a positive thing. So if we get to something, if we get to an answer that, yeah, great comment. You know, if you get an answer of minus 17 for your area between your curves, you know you had to have made a mistake, because the area between curves is a positive thing. Okay, so Fran and George are racing bicycles. They both cross under a bridge at the same time. So at the same instant, at time t equals 0. So, you know, here's the bridge. And at time 0, Fran and George are both biking under this bridge. So simultaneously, they cross under this bridge. Fran's velocity is f of t equals 20 plus 3t feet per second. George's velocity is g of t equals 40 plus 2t feet per second. So at time 0, Fran's going 20 feet per second, George is going 40 feet per second. At that instant, they both cross under this bridge. So George is going faster, so clearly George is going to be ahead of Fran. From that instant. I mean, at that instant, he's not ahead of her, but he's going faster. So A, graph f of t and g of t. Okay. Well, f of t is 20 plus 3t. So it goes through 0, 20, and it has a slope of 3. G of t starts at 40, so 0, 40, but it has a slope of 2t, of 2. Oops. So notice, again, George is initially going faster than Fran, but Fran's speed is increasing faster than George's speed is increasing. They're both speeding up. So quick question. Raise your hand if you can point to the place on the graph where Fran catches up to George. Want to mark it?
Wait, these are the velocities. No,
Okay.
not immediately.
If you go up on Court Street and you ask the person on the street, what's the time where Fran catches up to George? What are they going to say?
Wouldn't we have to find like, either a derivative or an integral of the graphs to then find the intersection point? Or am I wrong?
Say more.
Like, that's a, is that position or velocity?
Velocity.
Yeah, so wouldn't we want to find the integral of it to find the position and find the intersection?
Yeah, so what's going on here?
Same speed.
Same speed. Has Fran caught George yet? No. I mean, George is way ahead. He was going way faster than Fran originally. Fran is only going 20 feet per second. He's going 40 feet per second. So, but she's speeding up, and at some point, she's going to be going the same speed as George, but he's still going to be way ahead of her. So let me ask some more base. So I was hoping that one of you would take the plunge and give the wrong answer. Then I could appear wise. But you're not going to give me that. So question B. What does this area represent? The area between the graphs of Fran and George's velocity, or George's and Fran's. This is G of t, and this is F of t, from 0 to 6. So what is the number that's that area? What does that mean? Kenzie?
It's how much further ahead George is than Fran at time 6.
At time 6. Right. So think about this. I love doing arithmetic with shapes. So this shape you could think of as this. It's this shape minus this shape. Everybody get that? So this is the graph of G of t. This is the graph of F of t. These are velocities from t equals 0 to t equals 6. The area under the velocity graph is the displacement, or the distance traveled. This is George's distance. And this is Fran's distance. And so, as Kenzie said, this is how far ahead George is at time 6. Remember, they started at time 0. They were at the same spot. They had both crossed under this bridge, but George was riding much faster. So at time 6, George is going to be ahead, and the amount that he's ahead is going to be that area. Okay. Okay, the Jets won the first rumble. The second rumble is to answer this question. At what time will Fran's speed equal George's speed? Sharks and jets, and then one of you can send your representative up to mark that on the graph where you what you think that looks like. Sam, you look bored. Have you got it? Okay. Got to consult with somebody because you can't come up alone. But do it fast because those jets are clever. You can check with them. Yeah.
Do you get 20?
And then where does that?
Want me to show where?
Sure. Yeah. Mm-hmm.
Okay, so.
There's the graph. Yeah, wonderful. It's just simply the time where the velocities are the same. So you're going to set Fran f of t equal to g of t. So you get 20 plus 3t equals 40 plus 2t, and solve for t. All right, sharks and jets. Here's another question. Question D. D. At what time does Fran catch up to George? Trent, your hand is up. It's doing all sorts of stuff, but I think you have the answer. Okay. Marcy?
Are we looking for when the integral of the first function is equal to the integral of this?
Oh, you got to consult with the sharks. Yeah, this is. Did you get it?
I think I did, yes.
Okay, did you consult with your group and convince them? Who said that? Who said that? Okay, Jace, stand up and take your prize. Explain. Come to the board, though. Jace says t equals 40. Oh, no equations. Just do a picture. See if you can explain using the picture.
It'd basically be at the time where all of this area right here
Shade that in.
would be equal to some time at
Yeah. So notice those are, remember how you compute the area of a triangle? It's 1/2 the base times the height. So these triangles are sitting sideways. So their bases are going to be these little lengths. And so you think about this. This triangle has a base, whatever this height is. Well, we know what this height is. It's 20. because originally Fran's initial velocity was 20, George's initial velocity was 40, and then the height of this triangle is this distance, 20. So this is a triangle that's got a base that's the number 20, and the height is also 20. Now, these are just straight lines, so that if they keep going another 20 seconds, they're going to get to a point where this distance is 20. So it's going to be a triangle sitting on its side with its base oriented vertically, and its height is also going to be 20. So at the point where this area equals this area, that's going to mean that Fran caught up. Isn't that cool? So no math here. Just figuring out where, eyeballing it, where does it look like this area is going to be the same as this? Well, you can do better than eyeball. You can say this is symmetrical. These are, yeah, very nice. Okay, part 3. I'm not going to give you the title yet. Consider the curves x equals y squared minus 4y and x equals 2y minus y squared. A, sketch the graphs together on the same axes. Okay, so who can help me with this? Who can tell me something about the shape of these graphs? Raise your hand. So for instance, the graph of x equals y squared minus 4y. What's the shape?
Quadratic.
It's a quadratic, so what does that tell you?
It's symmetrical across the
Well, and what's the basic shape going to be?
curve.
You got to be more specific. They're all curves. What kind of curve? P, p, p. Starts with p and rhymes with parabola.
Oh,
Parabola. Now, opening which way? No. Because it's x equals y squared, not y equals x squared.
Is it facing like that way?
Yeah, it's opening to the right. So we have so from this we get that it's a parabola opening to the right. Okay, now what's often useful when you want to figure out how the graph looks without doing much work? We've got the standard form here. There's often another form that's useful. What's the other form that's useful? Starts with f and rhymes with actored. Factored, excellent, class, very nice. So y times y minus 4. So what does this tell us about the graph? Marcy?
The roots are at 0 and 4, y equals to them is the
Yeah, so intercepts at 0, comma 4 and 0, 0. So in other words, vertical axis intercepts. Okay, what about x equals 2y minus y squared? What's the shape of that? Jaren's avoiding eye contact, but I bet he's got the answer.
Parabola just opening left.
Good. Parabola opening left. Now, what else can you tell me about that parabola? Well, if I factor it, what's the factored form? Ian?
Y times 2 minus y.
Yeah, y times 2 minus y. So what does that factored form tell you about intercepts?
One at 0 and 2.
X or y equals 2.
Y.
Yeah, so intercepts, thank you. Intercepts at 0, 0, and 0, 2. So this is pretty cool. So we get to make a, well, you don't get to, I get to, I have the chalk. I have a parabola opening to the right, and it has intercepts at 0, 4, and 0, 0. So here it is. And then we have a parabola opening to the left whose intercepts are 0, 0, and 0, 2. All right. Somebody come shade the simple region. Trent? And while you're at it, color the top graph red and the bottom graph green. Top one's red, yeah, because it's hot. Great, thank you. All right, so Trent says this is a simple region, and this red thing is the top graph, and this bottom thing is this green thing is the bottom graph. Somebody draw in one of the little skinny rectangles of this region. Why did Kenzie do that? Don't rectangles go like this? And wouldn't we have a bunch of these rectangles side by side? Well, no, because you think about it, there, the top of the rectangle's on the red graph, the bottom of the rectangle's on the green graph, but over here, this rectangle has its top sitting on the top branch of the red graph and its bottom sitting on the bottom branch of the red graph. So this is not a simple region if our rectangles are oriented this way. So we have to think about this as it is a simple region, but we have to think of our rectangles going this way. So the title of this is Integrating y instead of x. To get the area of this region, we have to use this as our top graph. It is a top graph whose variable is y. So that's 2y minus y squared. And our bottom graph is this green graph, which is a function of y, which is y squared minus 4y. So our area, we're going to integrate imagine a stack of those rectangles on top of each other. So the area is going to be the integral from, well, starting down here at y equals 0. And so we're going to have top minus bottom. So 2y minus y squared minus parentheses the green graph, which is y squared minus 4y. And we have to have a dy, not a dx. Oh, but what goes up here? Sharks and jets? Who can answer that question? You got to consult with some of your other jets or sharks. Your hand's kind of up. You got it? Your hand's kind of up. Yeah, you got it? So we're wondering what is this height? How do we solve that?
Set them equal to each other?
Yeah, we have to set this height equal to that height. So we have to have 2y minus y squared equals y squared minus 4y. So let's add this to both, subtract this from both sides. So I get 0 equals 2y squared minus 6y. So 2y times y minus 3. So y equals 0 or y equals 3. Those are the two y values where those graphs cross. So we integrate from 0 to 3. Now let's clean this up a bit. So this is going to be the integral from 0 to 3, y equals 0 to 3. And I have minus 2y squared plus 6y. And then from here, I'm going to say this is straightforward. All right, so a bit of review. Raise your hand if you can tell me what that area is. Liam, your hand was up, but then you put it down. Yeah. How about this? Anthony?
It's Andrew.
Andrew, I'm sorry.
Pi r squared over 2.
Yeah. How about this? Who can help me with that area?
Do theta over 360 times pi r squared.
Wonderful. Actually, you should do theta over 2 pi. Theta over 2 pi. Fantastic. You got to figure out how much of the circle you have. If you have the whole circle, then theta is 2 pi. You just get pi r squared. If you have half a circle, then theta is just pi, so then you have 1/2. If you have a quarter circle, then theta would be pi over 4. So, sorry, if you have a quarter circle, you'd have theta equals pi over 2, and so then you'd have 1/4 of pi r squared. So this area is going to be theta r squared over 2. So that's the area of an ice cream cone. Now, your book, I could swear that at some point in this semester, we had to figure this out. Or was it last semester in Calc 1? Anybody remember that this is the formula? So the thing is, your book does a lot of kind of hardcore calculating of stuff that it's not really smart to do hardcore calculations. So let's figure out the cone area using integration. So this is difficult and silly and really dangerous. I'll be okay, but it is dangerous. So, because we already have a formula, right? We have a formula that you all can get behind. I think you just figure out how much of the circle you've got, and that's how much area you've got. So let's turn this cone on its side here. So this little bit of the circle, we've got this. And so this is theta. And we can think about this. I'm going to just draw the exact same thing again. We can think about this as two things. One is a triangle. And then the other is this little bit of a shape here. So we've got this area, let's call that A, and let's call this area B. Okay, so let's figure out the area of the triangle first. So how do I get that area? First of all, what's this y and what's this x? What's the relationship between y and r and theta? William?
R times the sine of theta?
Yeah. Y equals r sine theta. Because y over r is sine theta, so that means that y equals r sine theta. So somebody else, what's x? Some more hands up?
Would be r cos theta?
Yeah, r cos theta. So that means that the area is going to be 1/2 the base times the height. So that's going to be 1/2 of r squared cos theta sine theta. Hey, anybody know a trig identity? cos theta sine theta?
Is it code 2 theta?
Sine 2 theta over 2. Yeah. So this is 1/2 r squared sine of 2 theta all over 2. And so in other words, that area A is going to be r squared sine of 2 theta all over 4. I really hate the double angle things, though. I really like cos theta sine theta better. Okay, what about B? B is going to be this area. Now, this is part of a circle. Remember, this is x squared plus y squared equals r squared. So that means y squared equals r squared minus x squared. So if I take the square root and take the top branch, y is the square root of r squared minus x squared. So that's the formula for that. And where does this begin? This begins at that x value. And it ends at this x value, x equals r. So this area B would be the integral from x equals r cos theta to x equals r of square root of r squared minus x squared. Which is something that you can do. I don't want to do it because I would certainly screw it up. But you can do it. I can do it. Would involve, you'd want to do, probably you want to do a trig substitution. I don't know. But the thing is, it's hard. But you should get the same answer as over here. You should get theta. The amazing thing is when you do all this work, and if you have a really good day and you can simplify everything, you ought to get theta r squared over 2. Okay, so I bring this up because this is the kind of stuff you find in the book. If you were doing area between curves, this is an area between curves, this is the way you got to do it, it's going to be hard to do it. But we already know a geometry question. Now, in the last minute, I want to talk about something else. Just the reason I bring this up is because you have a really beautiful and really cool homework problem. Area of a loon. So a loon is this. You have a circle, and then you imagine a diameter of that circle, and through the opposite parts of those the opposite endpoints of those diameters, you've got another circle that intersects that circle there. And what's called a loon is this region. And you have a homework problem and so this circle is radius r, and this big circle is radius capital R. So little r, capital R. And your job is to find the area of that loon. Now the way that the book has in mind of you doing this is that you have a basic region. So you integrate, right? Thing is, it's hard on the scale of that kind of hard. You can do it, but it's hard. But think about ice cream. So simpler, think about shapes. So this loon, this thing, you could think about that as being, you can do kind of an arithmetic with shapes. It's this semicircle minus this little yarmulke. Oh, but we can make this simpler, because this is, the area of this yarmulke kind of thing is hard. It's like one of those things. But think about this as, again, some arithmetic with shapes. This yarmulke you could think of as a cone. We know how to get the area of a cone, and then minus the area of this triangle. So easy, easy, easy. Just do arithmetic, you get this area. It's really cool. So, but this is a hard problem that should give you the same answer. I don't think I was able to get that one last night. I was too bleary-eyed by the time I got to that. But this one I was able to do with the way the book imagines it, and it's hard, but then I did it with shapes, and it's a lot easier, and I got the same answer. So, all right, so sorry to keep you a little bit late. Thank you for recording, Gabriel.